So take a look at it. So it's a substitution problem.
I believe it's 135.
Yeah, it's page 135, section 2.5. 2x minus 3y minus 4z. That one there, right? X is negative 2. Y is 4. And z is negative 1. So now, how would you rewrite this to plug those values in?
I put 2 times with the parentheses.
Good.
Negative 2 parentheses minus 3, and then a 4 in the parentheses. A minus 4 parentheses negative 1.
Coolness. I like it.
Is that right?
Yep.
Okay.
So those parentheses are kind of like another way to represent an empty spot. Parentheses with nothing in it is an empty spot. So then you're just putting in there what the value is.
But they don't automatically mean multiplication.
Oh, hell yeah. So when you have something sitting next to something else, that's multiplication. There is no other operation in there, is there?
No.
There's no plus sign, there's no minus sign in between. They're sitting right next to each other. That means multiplication.
Okay, so
Cool.
2 times minus
Exactly.
2.
2 times negative 2. Because this symbol right there means multiplication, right?
Right.
So just because I plug a value into x, I can't change the operation. The operation says twice whatever the hell x is.
Gotcha.
So what is twice negative 2?
Negative 4.
And why am I doing that first? What am I going to definitely do last? What am I going to definitely do last? Subtraction. These subtractions are going to be last. Cool. It's not a bad idea to figure out what it is I'm going to do last, just so if you don't do it too early. All right? So 2 times negative 2, negative 4, like you said. Negative 3 times 4. Negative 12. You guys with me?
No. Why is that negative 4? Isn't negative times negative a positive?
But I don't have negative times negative.
Oh. Oh, you know, I'm thinking.
That's right. Okay. Can you write it as if we did? Or can you like show me like it was?
4.
Can you write it like how we're saying it so we could see the opposite?
I'm not sure what you said. What do you mean? Let me do this problem, and then we'll see any adjustments you might want to see what would happen if. Well, let's focus on what we got. Is everybody cool so far?
Yeah.
There's only one negative here, so it's still alive. There's only one negative here, so it's still alive. What happens in the last piece?
It stays 4.
Negative 4 times negative 1 is?
Minus 4.
Positive 4.
Positive
4.
4. I love it.
Negative 3. Positive 3. Or negative 3.
Now, I like the look I'm getting from some of you guys, and I don't mean that as, I don't like the look of some of you. Some of you guys are looking like, what the hell are you just doing? But right here, here's another way you could look at this that I personally don't like to look at it this way. You have a minus sign, and what's 4 times negative 1? Negative 4. But what's negative times negative?
Positive.
So, I mean, no matter what you do, you're going to get there. Those two negatives want to kill each other. So you can do it in 2 steps and say, no, Jeff, that's not a negative, that's a minus. I'm like, okay, cool. What's 4 times negative 1? Negative 4. And what do you get when you subtract? Negative. Oh, it's plus. I'm trying to show you the kind of things you should build into how you do a problem so you don't waste time on something that's unnecessary. Those 2 negatives are going to kill each other. I don't care what approach you take.
So can you just put in your head when you see that negative like that, just know that it's going to be a positive?
Yeah.
When you see that?
When they're multiplying. These are multiplying, right? So I know that that rule applies then, that 2 negatives will cancel when I multiply or divide. Yeah?
I'm just thinking that way over there, the one with the minus the negative 4, everybody's done it that way so long, you know. In your way, it's kind of, not you, but it's a different way. So I guess that's why everybody kind of gets that. I understand what you're saying.
Yeah. But I'm trying to get you ready for when that should not even be the problem anymore. When you get further, You don't want that to be something that takes time to rewrite. You want to just be able to get to that answer and move on, because your problem is going to take a page. And you don't want to take it a page and a half, because every time you see this, you're doing one extra step than you really need to. So I'm totally with you, and that's why I want to show you. So you can totally look at this. That's definitely -4. And that's minus 12. And that's minus -4. That's cool. But now minus a negative positive. So right here, that's -4 times -1 is +4. Just get you that one step quicker, which adds up. Okay, cool.
-4 and -12 is +16.
All right, well, no. Come on.
But you got to bring them, because they're two sides, you got to bring them down.
Are the signs the same or different?
Yeah, so it's -16 plus 4.
All right, let's hold on. So here the signs are the same, so you add them. 4 and 12 is 16, and you put the sign back on.
Plus 4. And that negative wins out.
All right, hold up, hands.
-20.
Hold up.
20. No.
Not 20.
12.
12.
So when they're different signs, what do you do? Subtract them.
Multiply.
16 minus 4 is
-12.
12, and the bigger one is negative.
Right.
Cool. Whew. Now, I mean, that's... and again, we have very, very different backgrounds in here. So some of you guys are sitting here saying, I can do this all night, I can do this by blindfolded, I can do this in this. Look great. Sit there and just...
No, there's a reason why we're in class, though.
No, it's okay. No, it's true. I know it's true. There's a few of you guys who are, why are we analyzing this to death? But, of course, I want to make sure we're all on the same page. And the easiest way to get this is just those two rules. It's the most direct way. I've talked about money. I've even talked about digging a hole and all stuff. Those are nice visuals, but when you get down to it, you just want to internalize the fact that you really are subtracting, because they are different. Parts of them will cancel with each other because they are different. Here, they're the same. They're going to end up in the same direction, so they're going to grow in that direction. Negative, negative, more negative. Different sign, smaller number. Why is it negative? Because the bigger one was negative. Right? That kind of thing, you want to internalize that and make that just second nature.
So you got +4, you take that away from the -16. Because it's a plus. It's positive.
Different signs. That's the key. Okay.
She's got a question.
Yeah.
So is it safe to assume that every single time like you have the -4 and the -12, that you could always change the negative to a plus sign and always add a negative to the 12?
So what we're really doing, I want to make sure you guys understand.
Added negative.
What we're really doing is, if I had something like, -11 minus 7. And the ultimate way to really explain this, what's really bad about it is we don't even learn this until later, and then there's no reason to come back to this. But do you guys know, let me see how many of you guys know this. Have you guys ever seen something like that?
Yes.
And you know what property is used?
Multiplication.
Distributive property, right? We put the 2 through. Does that look familiar to anybody?
Yes.
Cool. Does that not look familiar to anybody?
It's familiar, but I don't
No? Okay. So this is why it sucks, because this is the best way to actually describe what's going on here, but it's a little too early to use it, because I only use this property when we have this kind of thing. We're not even there yet. So a couple of you guys won't like this, but you got other ways to look at it. But if I actually do what I just did backwards, take a negative out, I'll get that. Want to get like -11 minus 7 if I put it back in? So I can actually think of it as taking it out. So that's really what's going on here. That's why the rule is, if they're the same sign, you add them and you put the sign back on.
Right.
So you actually, it's distributive property. But do you have to look at it like this? Especially if you've never seen this damn thing before. Of course not. You don't have to, because the rule takes care of it for you. But that's why we end up adding. So when you see this, same sign, so you add the numbers.
Put the sign.
Add the numbers, but then you put the sign back on. I mean, that's the rule, and I've given you why that rule works. That's where all the visuals come in. I owe you $11, I owe you 7, I owe 18 altogether. That's the visuals, that's the physical that helps you internalize those rules. You can make sure that it makes sense. If you put 4 here or something, or positive 18, you take a second, that doesn't make a damn bit of sense. I owe money all over the damn place. How do I have 18 bucks all of a sudden, right? That is complete wishful thinking. So I'm hoping that the physical examples I give help you understand why the rules are the way they are. Does that make sense? At some point you want to move past the physical examples, because that's just going to take time, and just internalize the rules. But we want to make sure you understand why the hell the rules work in the first place. You buy into them, and then you internalize them. So here, again, negative 18. If I have different signs, what would I do there? Yeah, subtract the numbers. The numbers are 24 and 11. 13, and which one's bigger?
Negative.
Negative, so it's negative 13. Okay, cool. I like it. Nice. Some of you guys are still looking at me like I'm crazy. That's all right.
No, I'm just the only thing that gets me is the minus 4 in the parentheses minus 1 times 4, and how that gets to be a plus.
So there's you can either look at it like that. 4 times negative 1 is negative 4, right? And there's a subtraction sign outside. And what's minus a negative? Positive. I mean, so that's straight up. And what I'm trying to say is, maybe start to get a little bit away from that and just go more directly. Negative times negative is plus. Right?
So what you're saying is at the end, if it's like that,
wherever that is in the problem. Wherever it is in the problem, you can do that. So if I had a problem like this, that's enough, right? What would you do first? Parentheses.
Yeah, these would be 3.
Yeah, which one's bigger?
5.
So it'd be negative. 5 minus 2 is 3. The bigger one's negative.
Yeah.
And what's negative 6 times negative 3?
18.
So what I'm trying to say is everybody cool with that?
Yes.
And then what's understood to be out here? A plus.
Positive.
We know it's positive. And in general, we don't write that because if there's not a sign, we know it's positive. Now, go with me. What if there would have been a 4 sitting there? Nothing would have really changed, would it? Don't I still do multiplication? You know, I do inside here.
And just bring 4 down.
And then I multiply these. But what's in the middle here? The understood plus sign. That's when it has to show up to show that it really is addition. So positive really is the same thing as addition. Negative really is the same thing as subtraction. It really is. That's why when I see this, that is negative 4, negative 1, which is plus 4. It really is. And, you know, you can do the intermediate step if you need to. I'm trying to get you to the point where you can lose some of those intermediate steps and gain a little bit of time in the middle.
No, I don't have a question.
Okay.
I have one more.
Yes.
Oh, I see. So there's not a negative sign on the 4 where the 3 is, so
that negative's still alive.
right.
There's no negative to cancel it out. That's
So
why that middle 12
if
is
there was a
negative.
negative on that 2, it would come down as a positive 4.
Because the 2 negatives would die.
Okay.
So that's all that's happening here is these 2 negatives are killing each other. Yeah.
As long as there's 2 negatives, you use it as a positive.
When you multiply
But if
or
the
divide.
negative is greater in the end.
No. Anthony, hold. You had it right. When you multiply, 2 negatives will cancel.
Right.
Right? When you add or subtract, the 2 negatives won't
Stay the
cancel.
same.
You got to be careful.
Okay.
All right, and I'm hoping that our discussions so far have made sense of those. It's really easy to mix them up sometimes, but I'm hoping the more you do it, the less you mix it up. All right, what always finds a way to screw us over? Minus and 0. Somehow they always find a way to mess us up. Right? It's true throughout all of math. Trust me.
30 years.
72 is the one I had.
72, section 2.5.
I'm not on that same page. Kind of like a trick question because of the way it's written.
Oh.
75.
See how it's written? 72.
Yeah. Let me start off like this. Let me show a problem kind of like that problem. what would happen here?
It would become a positive.
Yeah, what's the first thing you have to do? Are you allowed to multiply?
No.
No, you have to do parentheses, in which case absolute values are the same place as parentheses. So this is 11,
Bring it over.
and the negative side is still there. Is that negative still there to kill that one? No, so it's just negative 1. So now your real question, now I like that, you're sitting there saying, I didn't ask you that damn thing. But if I had negative x squared, and they tell me x is
-3.
negative 3?
Yeah.
Okay. When you put it in, it's like that, right? You want that blank spot, and what are you going to put in place of x? Negative 3. Can you cancel those out? Do you do multiplication before you do exponents?
No.
Hell no, right? Same thing as, see how the similarity is between here? I can't cancel those because I have to do this first. I can't cancel those because I have to do this first. Right? So what's negative 3 times negative 3? Positive 9. And that negative
Bring it in.
comes for the right.
Okay, so why, if that's saying x squared, why is that 2 outside the parentheses?
Because what is x? Negative 3. So if I write this, am I squaring negative 3? This is the fundamental question.
No.
And I do this a lot, but we keep forgetting. Am I squaring negative 3 here? Hell no. I am squaring 3 with a negative sitting out front. How do I square negative 3? It's like that. Parentheses help group stuff together. If I want to square negative 3, the parentheses help collect that as one thing. Because if you think about it, negative 3 is that one thing. Not really. There's a negative sign and there's a 3. So when I put the square there, it can only go right on what it's sitting on. That's all it affects. So if x is negative 3, and I write this, am I squaring x? No, I'm squaring a part of x. I'm not squaring the whole x. That's x.
If you did it the other way, where if you didn't have the parentheses and you had that 2 out there, and you said it's still be 3 times 3, would the negative still come down though? That sign?
Yeah, if I didn't write it like that, if I wrote it like this,
Yeah.
then that negative is here, and 3 times 3 is 9.
So isn't it still the same thing?
But you know what? Now, I'm not doing that problem, am I? All right. So if you took this problem and you wrote it, now you have to help me because I don't know how to write this without parentheses. X is negative 3. So right there, I'm like, I need parentheses no matter what to separate these two, so they don't become one giant, like the brows connected. But if I do this, those two negatives should be able to do what? They're right next to you. They should be able to cancel each other, right? But I know they shouldn't be able to, because this is negative square of something. That's going to come out negative no matter what. Because when I square something, it always comes out positive. Or if I square a negative number, negative times negative is positive. So the answer should come out negative at the end. That's positive with a negative sign on.
Okay, so if there was, I know there is, that would only other sign that would be out there would be a plus without the parentheses.
Yeah, if it was written like this,
Yeah.
these two negatives would cancel each other,
Yeah.
and you get 3 squared 9, which is the wrong answer.
Right.
Because what should really happen is I'm squaring a negative number. So I better square a negative number
First.
I have to have those parentheses. So the square goes to the whole x. If I don't have the parentheses, am I squaring the whole x?
No.
I'm just squaring the 3 part of x. I'm not doing what this says to do, which is square x.
Yeah, you exactly. You're including a minus in there that shouldn't be there.
Don't go there. So here, I've got to write it like this.
And so the negative 3 times a negative 3 is a positive 9, but
Yeah.
we bring that
But that negative is still there.
down.
Same way that negative was still there at the end.
That's what I'm just trying to
How about this? 2 times negative 3 squared. What would that be?
9.
Good. Right, you have the exponent first, so 2 times 9. Did that 2 change at all?
No.
Was there any reason for that 2 to change?
No.
No, it's just sitting there waiting for this guy to figure himself out, right?
2 times 9.
You guys with me?
Yes.
All right, and that's a weird way to say things, but isn't negative just as valid as 2? If that negative is sitting out there, isn't that like an understood 1 here, negative 1?
Right.
So if the 2 wouldn't change if it was sitting out there, why would the negative change? It just comes for the ride just like a 2 would.
That's right.
Because that square doesn't affect whatever's sitting out here, it just affects what it's sitting on.
So that symbol is just like a number. It's a 1.
Yeah.
Okay, I got you. So it's like an understood negative 1 out
It's
there.
an understood number.
I like it. We just don't write it because that saves us a lot of time over the long run.
Otherwise, yeah.
We'd go crazy.
Yeah. That's cool. I got that.
Anything else from homework?
And,
All right. So we're going to do that last section in chapter 2.
Oh.
What's up?
If, say we have the exponent on the absolute number, does that change anything?
All right.
Are we gonna have that?
Part of me likes the way you think, but real quick, just because you asked.
And I'm not trying to be an a-hole about it.
No, it's fine.
Yeah.
I mean, this is certainly something that could happen. What will save your ass always?
Doing the
Order operations.
parentheses.
So I'm doing here first.
Yeah.
Am I done with this piece? So I'm still in the very first level of order operations. What's the absolute value of negative 3? So that is
3. Oh wait.
3.
And you're making a parenthesis because you're separating from the minus.
Exactly.
Okay.
Yeah, because what does it say to do? Square whatever the hell this is and put a negative on it. That's what that really says if you look at it. So I'm going to square whatever the hell this thing is and put a negative on it. Right? And to tell you honestly, I really didn't need this. I don't need that because the negative's just sitting out in front of 3 squared. So at the end it's going to be negative 9, no matter what you do there. Yeah. All right. Okay. So we got one section in chapter 2 left, and it's actually one of the more important ones because if I had to pick and choose one skill for you guys to come out of this class with, and we go over a lot of them, but if you come out of this class with the ability to solve equations, you are golden. I mean, that's the cornerstone of early algebra, is just solving equations. Because then word problems suck to set up the equation, but you want the equation to be easy to solve. You're like, oh God, get the equation. Then you don't want to be like, oh God, I got an equation. You want it to be the easy step, right? Okay, so this
I love that I just want to make a statement and say I love the fact that you're taking the time to do this. It really means it's the cornerstone, like I said. Without this, nothing. You can't.
I want you. No, what do you mean? I want you to know I get paid to do this. Now, obviously I enjoy teaching. Don't take that wrong, but this is not completely out of the minus of my head.
A lot of people just throw it out there and just you better know it coming out of high school.
No, yeah.
This you're supposed to know
Well,
this already.
Math is one of the easiest things that leak out the head, right? It leaks out, and you can't catch it and stuff.
But a lot of teachers won't.
So a lot of you guys are in the situation where you haven't had math in a very long time. And now you want to come back and maybe do something that requires some math. So why would I make any judgments as to anything? I mean, there's a lot of stuff I can't do that you guys can do a lot better than me because you do it more than I do, right? And you've been doing it longer than I do. Why can I do math so well? Because I've been doing it my whole damn life. So I'm not, why would I, anyway.
I was watching your video.
All right. So this is section 2.6. Now this is a little intro to solving equations because the entire next chapter is focused on... What's that? Oh, it is in the blue. It is. But I want to do a little lecture first. Okay. And this is the part where students start to question why, because this is the part where you can solve a problem without algebra. And then you start to say, well, look at me, I just did it without algebra. Why do I need algebra then? Well, we start with very simple problems just to get the process down. So I don't want to go there yet, but if I give you a problem, don't just give me the answer out of nowhere. Show me the steps you took. Because here's an example of an equation. Now you can just look at that, and hopefully you can figure out what that has to be to make this happen. Right? And what does that have to be? 3. And it's because of the fact that we're trying to get the process understood. We want to start with an equation you can actually do without algebra. So that's not the problem. The problem is just getting the process of algebra understood. I know the answer is going to be 3. So I feel more confident already. Maybe I can then try to use algebra to get there instead of just guessing what's going to work and saying, oh yeah, it works. So here's the idea of equations. Obviously 2 plus 3 is 5. So that's an example of an equation where there's nothing unknown. Right? The whole idea of equations is trying to work out what x has to be, of course, to make it work. So what I like to do is start with something very concrete. And the cornerstone of solving equations is whatever you do to one side of an equation, you have to do to the other side. And let's see why. If I subtract 1 there, and I don't subtract 1 here, I end up somewhere bad, right? So if I do something to one side, I have to do it to the other side at the same time, and then it remains true. You guys still with me? Okay, cool. All right. So
on the equal sign, opposite the equal sign.
Yeah. What? So if we do something to one side,
equal sign being the boundary.
Must do the same thing to the other side. Thanks for saying, Anthony. That's true. When I say side, I mean sides of the equal sign. I love it. So that equal sign cuts it in half. Do something on one side, must do the same thing to the other side. Okay. That's the cornerstone of solving equations. And actually, that holds throughout all of math. How do you solve an equation? You start doing things to both sides to try to cancel stuff out, to get at what x is. So let me do something else here. So this is one thing I could do. So let's start over again at 2 plus 3 equals 5. So what if I multiply this side by 2?
You multiply the other side by 2.
Yeah, now how do I do the other side? I got to multiply the whole other side by 2.
Okay, so you go 2 plus 3.
2 plus 3?
It's 5.
Yeah, it's fine.
You go 2 plus 3.
So is that still true?
Yeah.
Twice 5 is 10. Cool.
Right.
Okay, so now let me get closer to where we want to be. Starting over again at 2 plus 3 equals 5. If I subtract 3 from this side, I better subtract 3 from this side, and then I end up with this incredible statement.
It says 2.
2 equals 2. Neato. So that's almost too simple. You guys are all like, wow, this is incredible, Jeff. How did you do that? So here's the true equation. Yeah, hopefully you picked up on a little bit of sarcasm I was laying down. So x plus 3 equals 5. That's a true equation. So when we I don't know what x is, but it is a number. It is a number that when I add it to 3 is 5. And I know we already all know it's 2, right? But how does the algebra work so that I can handle a more complicated problem? Where you can't just stare at it and know what it is, right? We're not going to be Rain Man.
There's other doohickeys everywhere. You just subtract 3 from both sides.
That's the technical term. So, see what I did here?
Yep.
So if I do that same thing here, why is that really nice? I'll end up with x equals something. And that's my goal in an equation, is to get everything down to the point where I have x equals, because then I know what x is. So if I subtract 3 from both sides, it goes away here. And on that side I get what we know it's supposed to be. So up here I knew it was 2. So then I ended up with 2 equals 2, and then we're like, duh. Here, I didn't know what the hell it was. But now I know it's 2. It's like somebody's hiding it from me. I'm not going to show you. I'm like, oh, you know it's 2 shit, right? I mean, you guys kind of with me a little bit?
Yep. So you're able to get rid of all the other stuff and just break it, just have it x equals 2.
So your goal is always x equals a number. You with me? So what if I had this? Let's see. What would you do to both sides?
Negative.
Yeah, because again, if our goal is to get x by itself, we actually end up doing the opposite of what's happening currently, right? If I'm subtracting 8, I better add 8. So if I add 8 to that side, I better add 8 to that side. So then I get x equals 29. Kick x. How do I check that? Plug it in.
9 plus 8.
Plug it in 29.
Minus 8.
Check. That works. All right. Now, again, this is the really simplest level of solving equations.
That's
Right?
what I need.
So you can kind of eyeball these and you know the answer, but we're just getting the process down. Yeah.
When I was doing the homework, I started getting stuff on equations that had x's on both
sides.
So I
Good.
didn't know which one to start with.
You're reading my brain. I don't like that. If you can read my mind, you'll know what's going to be on the next test this time. So, if I had something like this. All right, now tell me, keeping in mind what the goal is. The goal is x equals a number. What's fundamentally wrong with that I can kind of try to correct? My x's, like you just said, are on 2 sides. How do I get them to be on one side? So really the question then is, how do I get it to cancel on one side and effectively move to the other side? How would I cancel them out here?
You subtract.
Good. If I subtract x, then I'm going to leave just numbers on that side.
Right.
And of course, if I subtract x there, I better subtract x on the other side, right? So do you see the whole point here is if I have x's on both sides, I want to desperately move them all to one side. And what I really mean when I say that is make them disappear on one side. And effectively they move to the other side. Does that make sense? I have to do this to make that one go away, and then I have to do the same thing to the other side. So effectively it moves over there. What do I get? What's 2x minus x?
2.
No. Careful.
1.
This is a good point. Side note. Somebody help me out. What's x plus x?
2x.
2x.
So it's going to be 1x.
You with me?
Yeah.
What's 5 plus 5? Twice 5. 10. What's x plus x? Twice x. Is that cool? So when I see 2x minus x, well, I've got a couple x's here. I'm taking one of them away, so how many x's do I have left? 1x left. Yes, ma'am.
I have a question. So if it's 1x, you don't put the 1 right next to
Yeah,
it.
like earlier, it's an understood one. It's kind of a way for us to save a little bit of time by saying, and to be honest, if you really want to go crazy, there's an understood one there. There's an understood one underneath. There's an understood one power. I mean, there's a whole lot of understood ones that we're like, please don't make me write all that.
It's a 1 square.
Is that cool? So when I see x by itself, I know that means 1x. There's only 1x that I see. Cool. Be really careful. The only way to make that 2 go away, now watch, this is important. What operation is happening between these two? So what's the only way to make the 2 cancel? What's the opposite of multiplying? I'd have to divide by 2 to make that cancel. Right? Or if I wanted to kill the x, how do I kill the x? Divide by x to make that cancel, right? I can't cancel multiplication by subtracting. You with me? So really what this is I've got a couple x's. I take one of them away. I got 1 x left. Over here, those cancel, right? So x is 7. And how did I get there? Just by focusing on my goal. Get all my x's on one side and my numbers on the other side. That's my goal. And if I work towards that goal and get there, I know what the answer is. I know what x should be. So what this really, really means.
Now you
what this really means, you write the beginning over again up here so you can see a little better. When this is true, then that is true. So no matter what number you plug in for x, if it's not 7, this statement will not be true. So what do you get when you try to plug a 5 in? What do you get? Twice 5 is 10. 5 plus 7 is? Ain't gonna worry. The only number that will make this statement true is that number. And we found that by doing this work. So to check myself, I just plug the 7 in. Twice 7. Make sure you guys are still listening. Equals 7 plus 7. Is that true? 14 equals 14. Check.
Oh yeah, the 2x's.
So let me show you a different way to say this. This is way forward in our future. But let me see if you guys get this. If I ask you what number do I add 7 to get the same thing as double that number, that's exactly what we just figured out.
Oh, okay, gotcha.
Right?
So we're trying to get 2 times 7 is what we're trying to do.
Well, we don't know that at first.
Right.
But I could also say, what number do I add 7 to get the same thing as twice that number? That's how the equation would be set up. That's like the very beginning level of word problems are. And that's in our future. Not as far ahead in our future as you might like. They're coming up sooner than you think. Okay. How do you guys feel so far? I mean, again, there's a lot of different levels in this class. There's people that can do this backwards and forwards, upside down. You guys, let me give you just a couple to try on your own here for a minute and call me over if you need some help. So it would say solve. Let me make this. It's not freak out by that. Now in class, I will push you a little bit. It's one of those looks difficult, but it's not that bad.
Doing them, do you also want us to show it how we're checking it too?
Yeah, I think if I don't say it, I can't really take points off for it. But if you look in the homework, it does say solve, and then it says check. So if you don't, I will make you redo it. So you want to check your answer if it says to. Here I didn't say it, but we'll probably do it anyway. Otherwise, it's fun. There's a more direct way to do it. Instead of moving your numbers aside, maybe move the letters aside. Move the letter. So what's wrong? Remember always that your goal is x equals, right? So here you have an x. What's kind of in the wrong place? No, the x is okay. You want him by himself, so what's there that you don't want there? How do you kill him? If it's minus 11, how do you cancel it? plus 11. So do that to both sides. We'll put a plus 11 on both sides. So add 11 right there. So put plus 11 right underneath there. Yeah. And do the same thing over there. Yeah. So
I see what you're saying.
I want to get you used to the best way to write this for yourself. So put plus 11 just by itself. Plus 11. Now right there, just put plus 11 right underneath the 3.
You said negative?
So you're adding 11 to both sides. Put 11.
Just 14.
So now when you add those, the 11s cancel, right? So you're just left with x
Because then it turns to
equals 3 plus 11. And is that true? When you plug that number in here, does it work? Yeah. So you know you're right. So the whole, yeah. I'm hoping the one that gave you the most trouble was maybe the last one. And really, not a bad way to look at this is, on part A, what is in the wrong place? We know our goal is x equals number.
The x is in the wrong place.
No, x is
3,
fine.
I mean.
No, so it must be.
Plus
See how the negative 11 is with the x? But what's my goal? I want x by itself. So I can get rid of this dude, right? I can get him the hell out of there. What do? Is right now it's minus 11, so I want to add 11. Right? And the funny thing is, I'm doing my teaching my calculus students right now, and it's the same idea. Whatever operation I see, I do the opposite operation. Now they just know a lot more functions than we know, but it's still, whatever it is, I do the opposite of it. Right? So right now it's minus 11. If I add 11 to both sides,
14.
these cancel. So I'm left with x. Is that cool? And over here I get 3 plus 11 is 14. So if I did check it, I would put the 14 right there. And that does work. 14 minus 11 is 3. Thank God. Yes, ma'am.
What if I did the 3 instead? Same thing, right?
So, just help me out. What'd you do?
I took away the 3
Okay.
and then did the opposite. No, I did a positive 3.
Ah, okay. See, that's not fair. It's, I always have in my mind Indiana Jones. He's got a balance. Whatever you do to one side, you got to do the other side. So,
Okay.
if I subtract 3 there and I add 3 there, that's not fair. You've got to do the same thing to both sides. And it's all because, what is that? What is this? And I love this question because you're all like, I don't know what you want me to say, man. This is a number. This is a number. I just don't know what it is yet because I don't know what the hell that is. You with me? So, if I subtract 3 from this guy, and these are supposed to be equal, that's what that says.
Right.
I better subtract 3 from this guy also, or else it's not equal anymore. Now, before I get too far with this is not the way I would suggest to do it. And I'm not, not to make you feel bad or anything, but do you see how I want my x's and my numbers to be on opposite sides? Here I'm kind of loading this side down with everything. So if you did do it this way, you would get x minus 14 equals 0. Good. That side doesn't just go away. Oh, no, there's nothing. It's 0. So your last step here would be get those numbers over there. What would you do to kill the numbers here? You want x by itself. What's the opposite of minus 14? Plus 14. And you do eventually get the same place we got. It just took you a little bit longer, right?
Yeah.
But the biggest mistake I see is people do this, and then either that goes away, or actually what I see is this. And I want to be very direct about this. The biggest mistake people make with equations is you don't keep track of everything. So what I see is somebody will do something like this, but then the next step is this. Now, absorb that for a second. I don't know if that's what you did or not, but can you guys see what's wrong with this? Which side of the equal sign should the 14 be on? That side. So this is a fundamental misunderstanding of how this works. If it's supposed to be that, how the hell did it get over there? Right? So you want to keep everything in line. X minus 14 equals 0. If you desperately have to do that for yourself. You don't want that to be the reason that you get mistakes. It's because you did something and just kind of, oh, I'll just put it over there. That's the answer. I'm done. It's got to make sense how it got over there. You have to move it there yourself. Maybe. So here, what would I do? What's kind of in the wrong place? I'm supposed to have all my x's on one side, all my numbers on the other side. All my numbers are together. So what's in the wrong place? Yeah, more specifically, 2x is in the wrong place, right? He's on the number side. I got to wrangle him in. So how do I kill him on this side? Yeah. And whatever I do to one side, I immediately do the same thing to the other side. So now here's my 3. These cancel. So it's like plus 0, but I never write that down. Is that cool? Because that's not going to do it. It's just gone. Equals x. So I'm done. X equals 3. I want you guys to absorb that. So it's stupid important too. Everything has to be in the right place. Or else you get you get negative 14 when it's really supposed to be positive 14. And if you're out in the business world and you tell, boss, we're going to lose $14,000, when actually you're going to gain $14,000, you're probably going to get fired. You know? So that having the right sign at the end is obviously important. That's the kind of mistake you make. How do I check that? 3 plus...
3 times 2 times 3.
Good. 3 plus 2x, and x is 3, equals 3 times 3. 3 plus 6 equals 9, and that's true. So therefore, that is the solution. That number makes this statement true. Therefore, that is the solution.
Agreed.
All right. And finally, part C. Yes, ma'am. Sorry.
I don't get the B problem. I see where we've crossed out the 2x minus the 2x, but on the other side of the equal sign, we have a 3x minus the 2x, so we should have a 1 left.
Good. A 1x, yeah.
Yeah.
Right? Because I wouldn't say if I had 3 people in a room and 2 of them left, I still have 1 person, right? So if I have 3 x's and I take 2 x's away, I have 1 x left.
Oh, so the x is like a 1.
Yeah. So there's an understood 1 there.
Okay.
But you wouldn't just have the number 1. You with me? It's like, no, I was counting x's. How did I lose x's? 3 of them, take away 2 of them is 1 of right? So you still got to have the there.
Okay.
Cool.
It's just x.
So another way to look at it real quick is 3x is x plus x plus x. Is that cool?
Yeah.
And 2x is x plus x. So if I subtract those things, there's the 1x that's left. You guys with me? Some of you guys look like you want to kill me. That's a little disturbing. You're fine. All right. Whoa. What time is it? Is that 6:45? What is it? Is that thing right?
It's going too slow.
It's going too slow. All right, last problem here. What's the very first thing you can do, period? 4 plus 7 is 11. So, I mean, I don't care that 4 plus 7 is inside of an equation. If I saw 4 plus 7 sitting anywhere, I can make that stupid thing 11. Because that's what 4 plus 7 is. So that's a really good place to start, is just combine anything together. So you got less stuff to look at. Now, who's on the wrong side here? Actually, you go one of 2 ways. But the easier way is to make things not negative anymore, for example. So if I move that guy here, how would I do it?
Plus
X plus, yeah.
You with me? Because then here, what happens here?
Cancels.
Cancels. So I get 11 equals
X.
0 plus x is x. 0 plus anything is that thing, right? I like it. So then 11 equals x. It's almost too easy. It looked like it was weird. But it's still the same idea of If I got everything on one side, get them on the other side. Move my variables over to the other side. Get them on opposite sides, and then you're there. And then to check it again, 4 plus 7 minus 11. 4 plus 7 is 11. Minus 11 is 0. Check. It works. Yes, sir.
Can't you do it the other way?
Yes, sir. But I'm not quite there yet. I haven't talked about multiplying and dividing it all yet.
I mean, about 11.
Yes, but then you have to divide by negative.
Yeah.
So I haven't quite got there yet. So we'll get there right now. Okay, so with everything we've talked about, don't say anything out loud. What do you think you would do here? And again, don't say anything out loud. See how far that takes me. That was pretty good. That was a good long time. Normally it's like immediately somebody divide by 4.
Hey.
He goes, what is operation right here? Yeah, this is 4 times x. And what's in the wrong place? The 4. Because I know my goal is x by itself and numbers on that side. So I know the 4 is in the wrong place. Because the x's are close. There's numbers over there. Get the hell over there with your numbers, right? Well, I can't. Now, the biggest mistake I see here is this.
Oh.
Oh, I'm sorry.
Oh, no. I did that.
I can't see anybody's work, so.
I did that too.
Okay, good. Good for right now. This is the time to make a
Doesn't
mistake.
make sense. Take away the 4.
Here's why it doesn't make sense. Subtraction cannot cancel multiplication. You with me? 4 times x. I can't kill that by subtracting 4. So let me talk about a little side issue here real quick. Let me see if they make a big point of this. Probably not yet. I know. So we'll talk about it now. Alright. There's a little something called like terms. Right? How's this guy doing? Okay. Like terms. So somebody help me out. X plus 3x. That's 4x, right? Is that cool? Because I had 3's in there, I add 1 more, so I got 4 of them, 4 x's. So what's y plus 3x?
What now? Y plus 3? Depends what is y is,
I like it. That's the right answer. Y plus 3x. I don't know what the hell it is. I can't put y's together with x's. That's right. Right? And you can't say it's this, because what operation is this? So how the hell did addition become? No, don't do that crap.
Y plus 3?
So I can't do anything with that. Those are not like terms.
Not doable.
So I can combine numbers. I can combine x's. I can combine y's. But I can't combine x's and numbers. Right? So, for example, what's x plus 1?
1x.
No. It's x plus 1. Why is it not 1x? Because what's the operation here? What's the operation there? Addition cannot become multiplication. So I cannot consolidate those. Why can I consolidate x plus x? Because I got a couple x's, right? I got 2 x's. What do I have? I got an x. I got a 1. What the hell?
You got 1x.
I can't. I got 1x. And I got 1. I can't consolidate those. So like terms, you ready? Here's the official definition. Listen to me, I'm just talking slow. It must mean it's a note. Like terms means you have the same variable. And actually beyond that, you have the same number of variables in each. And what I mean by that is, so you have the same letter with the same exponent, just to get a little bit ahead of us. So for example, I cannot add x plus x squared. Because I got an x, and I got an x squared. What the hell? But I could add x squared plus x squared. How many x squares do I got? No, I don't. I see 2 x squares. I don't see any x4s there. Do I? You with me? I want to quash that right now. I see an x squared and an x squared. I see 2x squares.
That couldn't be 4x squared.
Now, why is it not x to the 4? I don't see any x4s in there.
I got you.
I see 2x squares.
Yeah.
That's what I see.
Yeah.
So that's exactly what math does, right? So, I mean, we know this is true. 9 plus 9 is also twice 9. Right? Nothing major there. So what's 3 squared plus 3 squared? It's 2 3 squares. I mean, it's not 3 to the 4th. You see any 3 to the 4ths in there? No, I got a couple of these. Right? So the power can't change because that would change what the hell it is. I'm just putting together what's sitting there. An x squared, another x squared. I got a couple x squares. So that's like terms. I have to have the same variable and the same amount, like the same exponent on the variable. I can't put those together, but I can put those together. All right. Now, why did that come up? Because can I do 4x minus 4? Are those like terms?
No.
No. That's another reason this won't work. So what will save your ass in an equation? You say to yourself, what operation is currently happening? What's the opposite of that? Division. That is what carries you through an equation. You are eternally doing the opposite of what you're like digging the x out. So if somebody poured a bunch of dirt on them, I'm going to take the dirt back off them. I'm trying to dig it out. So I divide by 4 on that side. I better divide by 4 on that side. So here, pop. 4's cancel legally. Over there, good. 2. Now, if you did make the mistake and do this, you put. You can spell, Jeff. I've seen you do it. If you did make the mistake like this, and you go to check, what's 4 times 4? Uh-oh, shit, not 8. Right? You don't then say no solution. No. That means your solution is wrong. You go back and you say, what did I do wrong? Right? You with me? That means the answer you thought it was ain't the answer. Go back and find the right answer. Now here if I check, of course, so that's a mistake. Here if I check this, 4 times 2, check. Right? 4 times 2 is 8. Because that's so, this mistake happens so often in almost every level I've ever taught. This kind of mistake happens. And part of it is, I mean, if it happens like once every 20 problems, I can deal with that because that's normal human error. Your brain just took a little vacation for a second. But if you really do this all the time, that starts to worry me. Right? And right now we're learning this, so I really want to quash this right now. You have to do the opposite operation in order for things to cancel. I can't cancel multiplication by using subtraction. That's impossible. How are we doing with that? All right, so what do you think that you do here? Throw some negatives in there, yeah. Yeah. You say to yourself, what's the operation currently? Division. And what do you want to get rid of?
That x.
No. Yeah, the 7's in the wrong place, right?
Right.
So then you say, so what is the 7 doing to my x? It's dividing. So I have to do the opposite. Multiply by that thing. Multiply by that thing. So here, cancels. It doesn't become 49 down there. They cancel, right? That's why I did it. To kill it. So on this side I get x equals minus 21. Right, the negative is still there. There's no other negative to kill it. All right, and again, if I check it, put negative 21 in, negative 21 divided by 7, negative 3, thank God.
That's actually a hard problem.
Why do you say that?
Yeah, it is.
I just think because you have so many different signs. You got division, multiplication, and
Oh, I see.
you know.
Well, we're the ones that brought multiplication into it.
Yeah, but I'm just saying.
I got you.
Oh, that, yeah.
Oh.
When you start adding them all together, that's when it gets.
I once had a professor that would be 4x equals 8, so x equals 2. He would just, as he wrote it, he would erase it. And we're like, Wait, what? And we'd have to remind him every time. We'd have, no, remember, let us write. This is before we had, phones that could actually do video. See what other weirdness they throw at you. Here, you guys try a couple more here. Uphill both ways? Oh, let's see. Alright, let's throw. I always got to push it. I do. In the interest of full disclosure, this last problem goes beyond this section, but apparently I don't care.
So nice of you.
As long as I don't put it on the test, you can't. It's a safe environment. Nobody's getting a grade right now.
Just sling you into the cornfield.
What's that?
You slinged him into a cornfield.
Whoa.
I said you just sling us into the cornfield.
You got to eat your way up.
Yep.
Sure, eat that corn.
So again, resist the urge to add 6. Because the operation here is multiplication.
So if you bring the 6 down, is it still, what happens to the negative?
Well, now listen. What's multiplying Rx? What's multiplying Rx? You want to get rid of the negative 6 then, don't you? So what do you do with negative 6? You divide. You do the opposite operation with negative 6.
Oh, yeah,
You see what I'm saying?
So, like, let's say you bring the 6 down, right? Bring the 6 and you go under the 48, you're going to divide. But, so is the answer going to be negative 8 or just 8?
Oh, yeah, it will be negative. But I want to make sure you got there for the right reason. So on this very first one, guys,
Are you going negative?
don't overthink this. The operation between these two is multiplication. So I know I want to divide. I want to divide by whatever isn't x.
Negative 6.
Negative 6. So there's no question that I'm going to divide by negative 6. You don't have to think, does a negative have to come with? No, there's a negative 6 there that I don't want. So I want to kill that negative 6. And so I have to divide by it. You with me? If I divide by positive 6, that negative's still there.
Yeah.
And that sucks because I want x by itself.
Right.
Whatever you do to one side,
Do the other.
so here the negative 6 cancels. 48 divided by negative 6.
Negative 8.
Negative 8. I love it. Because nothing is there to kill that negative. Cool. So I was right. Just want to make sure we got there the right way. And of course, if you check it, negative 6 times negative 8 is 48. So it checks. Cool. Sorry. While you guys are doing that, I'm going to pass this out before I forget the practice test. So you do not have to do this at all if you don't want to. It's just a study guide. You definitely don't have to turn this in because I'm going to give you the answer key on Tuesday. You with me? So Tuesday is review day. We're not going to do anything new on Tuesday. Tuesday.
Really good to practice.
Can we go over this again?
Oh yeah, I'm just doing this while you guys are here. We'll finish that out. Yeah.
No, I mean, like, the rest of this.
Oh yeah, Tuesday we can talk about whatever you guys want to talk about. Hopefully Matt can. No.
Would
Do
this
that in
be
your own
the-
time if you want to.
Would this be the standard length of the test, too? Or is that like normally
Roughly.
70 pages?
Roughly. Yes. No, 70 is crazy. 62
Okay.
in volume 1.
Yeah.
Is the answer to H negative?
Yeah, 11 times 2, yeah.
All right, let me catch up to you guys. Okay, G. Why is my x not by itself? The negative 11, and it's dividing, so what I want to do with negative 11? Multiply. So it's always the opposite operation, so it will cancel.
11, another minus 11. Do it on the other side.
Cool. So here, they cancel. We got x.
Equals minus 3.
What's negative 2 times negative 11? Positive
Oh, it is a positive.
22. You're multiplying, right?
So why do we use negative 11?
Because what is it that we want to get rid of? We want to get rid of negative 11. What's with the x? Why is the x not by itself? Because there's a negative 11 dividing it. So what do? The opposite operation with that, times negative 11. If I only multiply by 11, the negative would still be there.
11 times
But
11.
I didn't know the negative was there. I thought it was positive.
Oh no, that little negative's down there. Yeah, cool. Is that good? So our brains very often think the opposite of negative 11 is 11, but that's not what's going on. I'm doing the opposite operation. The opposite of subtraction is addition. And then our brain says, oh, that's true everywhere. No. The opposite of division of something is multiplication by that thing. You with me? So you got to multiply by negative 11 to kill negative 11.
So it's asking you to divide, you multiply. It's asking you to.
Yeah, whatever's currently happening, I do the opposite so it goes away.
With the same number?
Same number. Exactly.
Like whatever you.
Because, I mean, remember when we did this? What's there that's not supposed to be there? 7. What's the 7 doing? Subtracting from it. So what would I do? Add. So it's not, I didn't say negative 7 and then so make a plus 7. I said it's subtracting, so I'm going to add. I did the opposite operation with the number that's there. So this is division of this number. So I'm going to multiply by that number so it goes away.
So you're going to have the same number, right?
Same number. I like it. So, and of course if you check it, 22 divided by negative 11. There's no other negative to kill it, so negative 2, check. So this last one, I just wanted to, and again, full disclosure, it's from chapter 3. But it's the same idea. What's wrong here is, I got some x's on both sides, I got some numbers on both sides, so I have to somehow collect them all. I want, and just to help you out a little bit, I want that x to cancel here.
Subtract.
So that effectively moves over there. Are you with me?
There's no subtraction.
What?
How do I cancel positive x? Subtract. Right? You with me?
Why did you do it? It's hard.
I did it on both sides.
But I mean, I'm sorry, why did you choose the x minus 4 instead of the 2?
Or smaller, I would believe.
Is that why? Trying to use only the x of those?
I'm trying to figure out your question.
I'm sorry.
Why did I not do it maybe to here? Is that what you mean?
No, the 2x. Why didn't you get rid of the 2x?
Oh!
Group it.
Okay.
Yeah, why didn't you
And I
go-
told you while I was doing that I was helping, because this is a little in the future, but I know that if I move this here, it'll stay positive. Do you see what I'm saying? 2x can handle subtracting an x. If I subtract 2x from x, isn't that going to become negative? And in general, I want to stay away from making my variable negative. That always makes things a little harder than it needs to be. Can you do it that way? Hell yeah. But I try to keep my variables positive, so I don't have that as an issue. Right? We all know negatives become an issue. So why bring them in if you don't have to? So why did I choose to subtract x and not subtract 2x? Because I know this is going to keep my x's positive. You with me? It's not wrong to do it the other way. It's just opening up another place for me to make a mistake. Maybe. But the point I'm trying to make here is, if you have stuff on both sides, all kinds of stuff, you want to collect all your letters on one side and all your numbers on the other side. Because I know my goal is that. So if I do this, that goes away. 2x minus x. That goes away. 1x, good. Not 2. X minus 1 is still there. Equals. And I'm trying to be very deliberate with this. I'm really trying to get you guys to realize organization is huge here. Yeah.
What about the 2?
What about the 2?
What's a couple x's take away an x?
Wait, 1 and 2. Oh, okay.
Good. So it's not, this 2 in front means I have 2 x's adding. So if I take one of them away, I just have one poor little x by himself, right? So it's not that the 2 went away, it's that one of the 2 x's went away. So now I just have 1 x. Is that cool?
And that's what you want. You want to get the x by itself.
I want to get the x by itself. So now who's in the wrong place?
1.
Yeah, this guy's in the wrong place. How do I kill him? Opposite operation, add 1. So x equals negative 3. Good. So last thing I want to show you.
Can we check that?
Yes, of course you can. To check this, how do you check this? So let me rewrite the problem real quick.
Put in the calculator.
Now first I want to ask you, how do you put that in the calculator? Now, if you can figure that out, I still won't let you. So what am I going to replace x with? Negative 3. So I get twice negative 3 minus 1 equals negative 3 minus 4. What's twice negative 3? Second?
1. Negative 1.
What do you mean? All I did was replace x. I replaced x with what it is. That's all I did. I didn't change anything else. There's the problem. Wherever I had an x, I put a negative 3. That's all I've done. That's all you're allowed to do.
So always
Wherever there's an x, you replace it with what it's supposed to be. So what's negative 3 minus 4?
Negative 7.
Yeah, I heard more negative 7. That's good.
Oh, yeah.
And then, what do I do first here?
Negative 6.
Good. You multiply first. Negative 6 minus 1 is?
Negative 7. Negative
Check.
5.
So x equals negative 3 makes that statement true. So for some reason I want to do this. I'm going to do it before I decide not to. And we're not going to solve this right now, but I just want to show you. I don't know why I want to do this. I just want to show you where we're headed. At the end of chapter 3, you will be able to solve something like this.
Not cool.
Yep. It's fun.
Yeah. No. We're not going to... That was really creepy. Sorry.
Didn't do that.
That was really weird. This becomes... Remember that problem I had earlier? We had the 4 and the 7 and the minus 6. And so the first thing we did was consolidate like terms. So you can kind of see one of the first things I'm going to want to do... It's actually not this way, but I eventually I want to get my like terms together. So it looks more like one of those problems there. But what I actually have to do before that is that thing we were talking about earlier, just red property. So I mean, you can kind of see how to start attacking this thing, and our goal doesn't change. Our goal is still x equals a number. It's just going to take a little longer to get there, right? And can you look at that and just say, oh, yeah, x is 1? No. Can anybody? If you can, that's neat. I need to talk.
So the negative 7, is it going to multiply against that x plus 5?
Yeah, it's going to go to the x. It's going to go to the 5.
And the 2x will be 3 and the x.
And then negative is going to go through.
Oh, the negative, okay.
Yeah, the 2x is not in front of that thing, the negative is. And real quick, I know I said that's the last thing, but I lie sometimes. Since this came up earlier, I just want to show you this, and I promise immediately when I'm done, you guys can leave. This is a little ahead of us, but since this came up already, I just want to show you why this property is very simple. Order operations, what would it say to do first?
Inside parentheses.
And can we? What is x plus 1? Please don't say 1x.
X1.
It's x plus 1. I can't do shit with that, right?
Yeah.
But what does 2 something mean? What does 2x really mean? Don't say 2 times x. 2x is doing what? That's x plus x. You with me?
Right.
So twice something is that thing added to itself. So if I have 2 of these, that's x plus 1 plus x plus 1.
Right.
Now what's like terms in here? What can I combine?
X with X.
X plus x is 2x.
2X.
And what's 1 plus 1?
Plus
2.
So look what effectively happened. Screw the middle step. Look what effectively happened. 2 times x, 2 times 1. That's why distributive property works. It seems like it's violating order operations.
It's not 2
But it's
times
just-
X plus 1? I mean plus 2?
Yep. It's just rewriting the problem in a different format. And then I could combine like terms. But the shortcut just says multiply that 2 and this 2 times this. So that does make some sense. But this is really why it works.
And would you leave it as 2x plus 2 or what?
Yeah, right there, that would just be 2x plus 2. But you can see now, you can see why, I mean, doing all that would work. Get all your like terms together, blah, blah, blah. Okay. That will definitely not be on the test unless I put it as a bonus problem. I might do that.
Make
All
an
right,
easy
guys.
bonus.
Huh?
Make an easy bonus. The third.